Welcome to P1. In this video we're looking at regions. This is unit 3.7. So often in this you get, or certainly in the questions, you'll get a region that is often labelled R and is shaded. So maybe, you might get some lines on a graph, an area that is shaded, and maybe it has, the letter R for the region within it. And it might give you what these equations are, for example, like that, and ask you then to describe this particular region. Okay, so that's one type. The other type will be that it'll give you questions, so maybe something like, a set of equations which are essentially a set of instructions that you need to use to create your region R, your shaded region. And what I would say is, and we'll do this when we look at them, if you've given the set of instructions, what you tend to do in that is, or what I would always do, is get rid of your regions, so you're actually shading the regions you don't want, which is the opposite to what you get within a question. Now, let's look at this first example. Now, before I do start, let me just bring to your attention that when we do see a question kind of like this on a coordinate grid, shade the region, often this type of question would be on an actual graph paper. Okay. However, just doing it on here digitally, it's a little bit harder to do. So I'm just going to do a sketch. But usually within the question, and you'll see them later on, it'll say the word sketch when I want sketch. And it'll use like coordinate grid and so on like that. And it'll actually have the graph paper in the question in your exam if it wants you to draw it accurately. Okay. So let's get started. Now, when I come to draw these, the first thing I want to do is essentially replace each of my inequalities here with an equals. So x equals 2, y equals 4, and y equals 2x minus 6. These are the graphs I'm going to draw. Okay, and anywhere where it was an inequality which also had the equals, so greater than or equal to, less than or equal to, I'm going to draw with a solid line, and anything where there's no equals, like this one which is just less than, I'm going to draw with a dashed line, dashed or dotted line. So let's have a look at the first one, x equals 2. So a lot of these you should know how to draw, they shouldn't be too difficult for you. But we'll have something like this, x equals 2, nice solid line. In fact, I'm just going to draw this in black so it stands out nicely. So that's the line x equals 2 there. The next line I'm going to draw is y equals 4. So y equals 4 is obviously going to cross the y-axis at 4. But in this case, it's going to be a dashed or dotted line because the inequality doesn't actually contain an equals in it. So that's saying that, a value can't be on the actual line. So with the x equals 2, it can be on that line because it's greater than or equal to 2. Then my final value, or my final graph here, is y equals 2x minus 6. Okay, so, plot a couple of points here, for example, when x is 0, y is minus 6, so that coordinate, kind of obvious. Equally, you can look at when y is 0, and then we can see that x is 3 in that case, so like 3, 0. So we're going to kind of go crossing somewhere like here and somewhere down here. It doesn't have to be perfect for my sketch. Obviously, if you're doing this on graph paper, you'll need to make it a little bit better. And this is a bold line. So I've kind of drawn all my lines on here, but what about the region that is shaded? Well, we want greater than or equal to 2. So it's got to be to the right of this line. So this line, we want to the right of it. So if I talk about just getting rid of my shading, so what I'm going to do here is I'm going to, hopefully you can see this, a very pale grey. I'm kind of getting rid of everything to the left. Sorry, just making that a little bit darker there. Now we want less than 4. So it's less than this line for y. So essentially I'm getting rid of everything above it. Yeah? So it's just leaving me with less than. Now you can see that essentially I've only got 2 regions left. Essentially inside here or here. That's all I've got left. So I want less than or equal to, which is below this line. So I actually want this region here. Okay, so I'm actually going to get rid of everything above this line, leaving me the region that is below it, which is this region here. So just give that a little bit of shading to show you which region we're talking about. Now, a lot of people often say, well, it's a little bit confusing sometimes. I get the horizontal and vertical lines. That's kind of obvious, but the diagonal line I'm not sure about. Okay, and I do get that quite a bit. So let's have a look. So first things first, I know this one crosses at -6 here and it's crossing at 3 there, just to give you a little bit of perspective. And we know that this line is at 4, for example. Now we need to pick a coordinate. So somewhere to the left, to the right of 4, and obviously, to the right of 3 and below this 4. Now, when you come to do this, on actual graph paper, it'll be far easier to pick a point. Okay, and one point that I know within this region is 6, 2. Okay, and if you draw this out accurately, you'll be able to see, that particular coordinate. Once I've got this coordinate, all I do then is just plug it in to that graph. My y is 2 and my x is 6. So 2 is less than or equal to 6. Well, that's obviously correct. If I picked a point that is above this line, then it wouldn't work out. Okay, so that's how I know I've definitely got my region in the right place. So if I have a diagonal line, like in this case y equals 2x minus 6, I want to pick a coordinate that I know is in this region. And once I've picked that, I can just use the inequality to double check. So I'll do it again, a second choice. For example, I know that 5, 0 is going to be in this region. Yeah, so if I'm looking at the coordinate 5, 0, y is less than or equal to 2x minus 6, y is 0, 2 times 5 minus 6, 0 is less than or equal to 10 minus 6, 0 is less than or equal to 4. Clearly correct. Okay, so I can just pick a coordinate to double check my answer. So just to recap, the horizontal and the vertical lines really easy to determine the greater than or equal to. Sometimes with the diagonal lines people do get a little bit confused. If you're confused, pick one coordinate that you know for sure should be in the region you want to shade, and if it works out, you've got the right region. If this obviously didn't work out, then you'd know actually I needed the region above it. Now, in this example, you can see we've got a slightly different way of writing it. Sketch the graphs of y equals this, x equals this, and x plus y equals this on the same axes. So, it's just a sketch. Again, start off with my axes. And then I'll tend to do the quadratic first. So we know here we've got x is equal to -2 and x equals 3. So we know it's got to cross at -2 and 3. And 2 times -3 is -6. So it's got to hit at -6. So we've got a rough graph here, something that looks like this. Again, you know, it's a sketch, it doesn't have to be perfect. And I've got my first one. So this is my y equals x plus 2, x minus 3. Now, x equals -3. So we've got here, you know, x equals -3. I'll do this one in a different color. You know, use a few colors up in this one. Then we've got our x equals -3. And then finally we've got our x plus y equals 2. These are nice easy graphs to draw. Okay, if it equals 2, it means that it's going to go through 2 on both axes. So something like this, going through 2 and 2. Okay, and that there is a very quick and rough sketch of those 3 graphs. Now it asks me to shade the region. For this, you know, on the same axes, it shouldn't be too difficult. So what I'm going to do is, you know, I'm going to get rid of the regions first, like I did previously. So, you know, we're just going to take my first one, or the easiest one, which will be this x is greater than, oh, -1. I've drawn -3. What an absolute idiot. Give me 1 second. Sorry about that. Total apologies there. I was reading off this bit rather than this bit. Okay. And, you know, let this be also be a little lesson to you, you know, about reading things carefully, you know, maybe even taking a bit of a highlighter to some of your questions as you're going, you know, through them. So let's get back into where we are. So we want to get rid of the regions around it first. So I know it tells me to shade the region, but I will always very faintly get rid of the regions that I don't want. So I want greater than my curve. So looking at this, greater than this curve will be above it. And if I'm unsure, pick a point I know. So this 0, 0, 0 plus 2, 0 minus 3, so 2 minus 3 is -6. Y, which is 0 here, is greater than -6, which is true. Okay, so that is the right region. So we are actually getting rid of this region kind of all below or on the outside of this curve. Next, I want greater than the -1, so I'm going to get rid of this region all the way down here. And finally, I want less than, so x plus y is less than or equal to 2. So again, it should be this region in here. Pick a point, 0, 0, 0, 0, so 0 plus 0 is less than or equal to, that works. So I know that is my region, so I'm getting rid of this region here. Now, again, I know it says, like in the question, shade the region, but what you will notice if you do some of these papers, that it will often say it's all about that consistency. So if the candidate has shaded the regions that, you know, he's eliminated, that is also fine. So this is my region that I want here. Okay, so that is kind of how I would go about approaching this type of question. just think that getting rid of your regions is far easier than trying to shade the specific region right from the start. Okay, so and you can always do it in faint and then do it in really bold then, or in pen when you do the actual region if you want to. Third and final example. So here we've got a diagram drawn for us. We need to essentially explain what values or what inequalities will represent this region. So let's start with the easy ones. Okay, so we're definitely, it is here bounded by the y-axis and bounded by the x-axis, isn't it? So we can say for sure that x is greater than or equal to 0, y is less than or y is also greater than or equal to 0. So that is just my y-axis and my x-axis there. So obviously the y is x and above, this x-axis is y equals 0 and above. Now I've also got a third one here, another vertical, which is x is equal to 3. We want less than or equal to that, so we will put that x is less than or equal to 3. And before I move any further forward, you can see there's actually between 0 and 3, so these two can be replaced by a single one. So x is less than or equal to 3 but greater than or equal to 0. So I can get rid of these two and it's now been replaced by a single inequality. So I've got two inequalities. Now I've got two left to do. So we've got y is equal to x plus 1, and we want actually below that line, which will be here. Okay, again, checking below that line just to make sure. You can pick a straightforward coordinate just to make sure that it works. For example, I know this is on the line, but 0, 0, we'd have 0, 0, and 1. So, just checking, we should be expecting a less than or equal to here. If this is 0 and this is 1, then this inequality works. And then final one is this dashed line. Again, we want less than, so x plus y less than 4. No equals on this one because it's dashed. And again, check a point that is you can ignore the other ones for now, but check when it's definitely below this. For example, 0, 0, so 0 plus 0 is less than 4, that works. So these 4 are my inequalities here. And what I would say is the ones that people will do is they'll do this, they'll do this, they'll do this, and they might forget about the axes in this kind of case. Okay, but it's clearly bounded by the axes. If it wasn't, it would be shaded further across or further down. So just be careful with that. So a couple of quick questions to get you started, and then I've got a few more questions which are all past paper exam questions of the last couple of years. Some of them are whole questions, some of them are just the part of the question that involves the inequalities and the regions. Okay, so don't forget to pause as you go through and check out the answers at the end of the video. As before, I don't have graph paper, so I'm just going to do a quick sketch just to show you, this one. You, of course, will have this drawn accurately, far better than mine, but this should give you an idea. So obviously we're looking at when y equals 0, so we've got x squared minus 2, x squared is equal to 2, x equals root 2 plus or minus. So that's my first set of coordinates. And then looking at this second one here, we're looking at y equals 9 minus x squared. Again, I can solve it the same way. I can also remember that this is the difference of two squares. So x is 3 and x is minus 3. So I've got two options. I could have done it the same way as I did this one, but just to get the points along here. So we've got a minus x squared graph and a positive x squared graph. So the positive x squared graph is between root 2 and root 2. Okay, and it's going to hit at negative 2. So a nice symmetrical graph, and as I said, you should get a nicer drawing than me. Now the second one, I'm just going to pop up in blue so you can see it nice and clearly in contrast. So here we got like between minus 3 and positive 3, and of course it's going to hit 9. So we get graph, something, it's not the best of graphs here. Just doing a bit of deleting there, so you won't quite see the graph that I've just deleted, but it was pretty bad. So there we have it, our sketch. Okay, now you want the region that is greater than the graph I've got in black, but less than the graph I've got in blue. So that region is going to be this region here. It's that region that is in between the two. Okay, so hopefully when you did yours, obviously more accurately, but when you did yours, you got the same region. Again, I'm just going to sketch these, but you should have something very similar, but should certainly look better than mine. So y is greater than negative 4. It's going to be a dashed line because it's got no equals. Y is less than or equal to 3. Sorry, x equals less than or equal to 3. So somewhere like here, and it's going to be a bold line here going through the 3. Okay, so just pop in on the graphs that I've drawn there. Now I've got two graphs left. X plus y is less than or equal to 4. So we're looking here, it's got to go through positive 4 on both the x and y axes. You can get that just by substituting x equals 0 in and y equals 0 into there. And it's a bold line. And then finally we've got our, let me just pop in the x plus y equals 4 for that graph. And then the final one is simply y equals x. So this one obviously goes through the 0. This one's going to be a dashed line. Because we don't have that equals within our inequality. Now the region that we look to satisfy, we can see that it's greater than or equal to minus 4, so above this line, less than or equal to, greater than minus 4, less than or equal to 3, it's below this diagonal, and it is below this diagonal. So we're looking at this area here. So my region, and in terms of my shading, we're up to here, this whole region. And again, you just want to pick a coordinate if you want to test it. So, if I wanted to double check this, I can look here, x-axis, okay, less than 3, greater than 0. So let's pick a value, say 2. So this would be, say, the coordinate 2, 0. That is in my region, and I can check that in all of my values. So putting 2 into here, 2 is greater than minus 4. Correct. Sorry, wrong one. Put 0 into here, 0 is greater than minus 4. Correct. 2 in here, 2 is less than or equal to 3, correct. 2 and 0 go in here, 2 plus 0 is 2, 2 is less than or equal to 4, correct. Into the final one, 0 is less than 2, correct. That coordinate I know is in my region and it satisfies all my inequalities, so I know I've done it right. So always do a check at the end. Yeah, pick a value, a coordinate that you can see that's in your region and use it to double check your answer. Okay, you should always either do that as you do the question or leave time for that at the end. Okay, important you don't drop marks on these easy questions. Now, look at this one. We've got a little bit of information. First, we need to find this coordinate here, where these two intersect. So this line is y equals 3x plus c, as we don't know our value of c. This one is y equals 2x squared minus 50. So these two things, we've been told. Now, quite clearly, at this intersection point, which my arrow is pointing to, that's going to have an y value of 0, isn't it? So if I use the equation that I know, substitute y equals 0 in, so you put y equals 0 into here and get 0 equals 2x squared minus 50. 2x squared equals 50, x squared equals 25, x equals plus or minus 5. So now I know that that's 5 and that's minus 5. Knowing that minus 5 means I can substitute x equals minus 5 into this equation. So y equals, now at that point we know that the y coordinate is also 0, don't we? So 3x plus c, y is 0, 3 is times by minus 5 plus c. So we've got minus 15 plus c, so c is 15. So now I know that my equation is y equals 3x plus 15. And that's important, isn't it? Now it comes to, defining my region. So we want y is greater than or equal to 3x plus 15. We want y is less than or equal to 2x squared minus 50. And I'm pretty sure when this actual exam question came up, this is where a lot of people stopped. But there's a little bit of an issue with this, because just stating, less than or equal to 2x plus 50, there is a second region that works. If I look at these two regions here, greater than my line and less than my other one would also mean that this region should be shaded if I only have these two, because this also is greater than this line and less than this line. So I've got to make sure that I discount, this region there. So I want to get rid of this red region. So to do that, I just need a third inequality. So you think about this inequality straight down here, and we can add that in. So now we can just say also we want that x is less than or equal to minus 5. Now that means that we can essentially get rid of this black region, this red region here. That will no longer exist. I can just go ahead and totally rub that out. And there I have my regions. So you just need to be careful, when you set your regions, they have to work solely for what it wants. This one also worked here, which is why we had to introduce a third region. Okay, effectively, this is the answer they tend to look for, but if I picked anything kind of less than or equal to this 5, or certainly less than this 5, I can't really get it marked wrong there. Okay, now in this one, what I want to first do is put these values on. So 2y equals x, so this is y is equal to half x. I like it in that tone. And, you know, I can pretty much say that this is y is less than or equal to half x. I can see that inequality straight away. When I'm looking at my curve, that's y equals 2x minus 1/8 x squared. We're going to want above that, so we're definitely going to want a greater than or equal to 2x minus 1/8 x squared. So these are two of my answers straight away. Now, in terms of my other answers, okay, again, like the previous question, you know, these two answers alone, okay, will give me an additional region, which I need to dismiss. So I'm going to need this one here. So I'm going to need this point, and I'm going to need this region here. Okay, so that's one region that I'm going to have to find. I can find that by looking at the intersection of my two graphs. Now let's look at the L2 line. So that's going to come, first we're going to need where OC hits the x-axis. So y equals 2x minus 1/8 x squared, and we know that y equals 0. So 0 equals 2x minus 1/8 x squared. 1/8 x squared equals 2x. Multiplied by 8, x squared equals 16x. Now, very tempting here just to kind of divide by x, but that's not what you should be doing. Obviously, I should be factorizing. So take x out and we get x minus 16 in semi brackets. So x equals 0, x equals 16. So this point here must be at 16. So L2 is essentially the line x equals 16, or the inequality where x is less than 16. So I've got my three main inequalities here, which I'm going to write in red. So we've got y is less than or equal to a half x, y is greater than or equal to 2x minus 1/8 x squared, and x is less than 16. Now, I was talking about, you know, whether there was another region, so let's just double check. Greater than this curve, but below this line. Greater than this curve, below this line works everything this side and this side, doesn't it? Greater than this curve, below this line. Less than this line, yeah, this one, this region here would still be part of it if I only use these three values. So I actually do need a fourth value, or a fourth inequality. Using that intersection point could be 1. Let's look at that intersection. So we'd have a half x equals 2x minus 1/8 x squared. I'll multiply through by 8 just to make it nicer to deal with. So that gives me x squared minus 12x equals 0. So we got x minus 12 equals 0. So we've actually got x equals 0, which we know, and x equals 12. So our fourth and final value here should be that x is greater than or equal to 12. But essentially, anything where I've got x is greater than 0, all the way up to that 12 would work. Okay, incidentally, I should actually mention that in this particular exam question, it only gives you the 3 inequalities as the answer, which, as you can see when I was talking about it, is actually incorrect. Not sure if they adjusted that afterwards or not, if I've just got an early mark scheme with that on it. So this one has a couple of bits beforehand based on a previous unit. So we've got a couple of coordinates. So we've got our minus 2, 13 for P, and we've got our 4, negative 5 for Q. So first one we want to do is find that straight line that goes through P and Q. And you can do this two ways. You can do it all in one equation, or you can first use the two coordinates to find the gradient and then substitute it into y minus y1 or y equals mx plus c. Up to you. This is the way I'm going to do it. So I'm going to look at the gradient first. So I'm doing my P minus my Q essentially here. Okay. So that gives me 18 on the top, minus 6 on the bottom. So gradient of minus 3. And then I'm just going to use the Q, just because those values just look a little bit nicer. Y minus y1 equals mx minus x1. Obviously, I always write that down. It's good. It makes it stick in my head. X minus 4. And be careful here, you know, often a mistake I will often make at this point is that sometimes I'll put the x coordinate into the y and the y coordinate into the x. So you do need to be a little bit careful and not rush these, as it is quite easy to make those kind of mistakes. And obviously then take away the 5 at the end. So that gives me my equation, which is called L. So L here is y equals minus 3x plus 7. Does it make sense? It is a negative gradient. It does cross below the value of P, which is 13 for the y. So this does make sense. Now that's part A done, and we're going to need it for our final bit. Part B wants us to find the equation for C. Now for something like this, I often like to approach it like when you've completed this square, because when you complete this square, you have your x value inside the brackets and that y value outside, don't you? You know, like x is 4 when y is minus 5 is a minimum point. The only thing with like something like this is that this could be multiplied by something here, and it'll still have that minimum point. And that is then where the second point comes in. So the minus 2 and 13. So I want to find this value of A. So I'm going to use the minus 2 and 13 to double check or find it. So minus 2 minus 4 squared minus 5. So we get 13 equals 36a minus 5. So 18 equals 36a. A equals a half. So my equation is y equals a half x minus 4 squared minus 5. Now I've got my second equation, or the equation of the curve. Now for my set of inequalities, I'm going to do that in red here, just so it stands out. So we want above this straight line, so above L, so we want when y is greater than or equal to negative 3x plus 7. We want below our curve, so y is less than or equal to a half x minus 4 squared minus 5. Obviously you could have had this expanded out, which I think is something like half x squared minus 4x plus 3. Top of my head there, might be a little bit wrong with that. And then finally, don't forget this third inequality here, which goes to the P. So that is x is less than or equal to negative 2. As we know, the x coordinate of P is negative 2. And I need all three there to get my answer. Now, for this one, we need to sketch two of these graphs. So y equals x plus 2, nice straightforward graph first of all. It's going through a positive 2, it's got a gradient of 1, So something like that, y equals x plus 2. Then my next graph, I do need to factorize this. So it's going to be an x and an x. It's going to be a 2 and a 3, isn't it? Minus 3 plus 2. Therefore, it's going to cross out x equals 3 and x equals negative 2. So x equals 3, I don't know, somewhere over here. Sorry, x equals negative 2 is actually going to be this point here. And then x equals 3 is just somewhere over there. And of course, they're going to cross at minus 6. So here we've got it, something like that. And of course, that will eventually go up and cross somewhere up there. Just be careful of this, this minus 2 here. You can just double check it, put minus 2 into here. And of course, the y is 0. So you know it is the same. So that's part A done, isn't it? But part B then says, on your sketch, show by shading the region R, defined by the inequalities, this and this. Now, remember that this is show by shading. It doesn't mean you have to shade the actual region. You can shade the ones you want to get rid of. Okay, there's nothing wrong with doing that, and that's exactly what I'm going to do. So we want x is less than x plus 2, so I'm actually just going to get rid of initially everything greater than x plus 2. And we want y is greater than my curve, so get rid of everything that is less than that curve. So my region here is this region. Okay, of course you can shade the inside if you prefer. And I'll do that just to show you so it stands out nicely. But shading the outside and then labeling the inside region R is perfectly acceptable. Okay, find, or hence or otherwise, find the set of values of x, or for x, for which this is true. Now, looks a little bit confusing, doesn't it? But let's put our two equations together, because this is what we've been dealing with throughout, isn't it? So put these two together in terms of essentially them intersecting. So x plus 2 equals x squared minus x minus 6. So we can see that x squared minus 2x minus 8. Oh look, it happens to be exactly the same as what it wants us to find. So it's actually the x values along here. So greater than minus 2, less than whatever this value is here. So we do need this intersection point here, which of course we can get solving these equations. X minus 2x minus x squared minus 2x minus 8. So x 0. We know x minus 2 is 1, so x plus 2 has got to be there. So this must be minus 4. And yeah, that works. X equals minus 2, x equals 4. So this one is at x equals 4. So my inequality for C is that x is less than or equal to 4 and greater than or equal to negative 2. Okay, don't really need to use this particular sketch for it. I could equally have used, drawn this as a sketch, these 2 points, and then done it because, it's hence or otherwise. So, if I was doing it normally, I would have gone like this. I would have sketched this after solving it, knowing that x is minus 2 and x is 4. It's a positive x squared. Okay, I want lower, so I want here, so I want left there and right of that. Easy. Okay, so that's how you normally do it, but of course you don't need to because it is all about essentially this region. Okay, so it's where this value, hit at 4, and it's just those set of x coordinates. final question, if you're still with me and this is one of your first times to be here, or you have been here a few times and you haven't subscribed yet, please do hit that subscribe button. Just helps me out. Thank you. Right, let's get into this question. So we need to first find the coordinates of m and the coordinates of n, and I've cut out a little bit of this question here, but we're essentially looking at part C is what we want to do. Okay, so I'm just going to put down what the coordinates of m are. In fact, let's actually work it out. So m is the minimum point of C. So y equals x squared minus 5x plus 13. Okay, x minus 5 over 2. So what I'm doing here is completing the square. And here we have it. So m has got to be the coordinates 5 over 2, 27 over 4. Or, 2.5 and 6.75 if you did it in decimals. Now, knowing m, I can find what the equation of L is. So L has coordinates 0, 0. And it also has this coordinate m. Okay, y equals mx plus c. C is obviously 0, so we can get rid of that. Y equals mx, just use the one coordinates, 2.5 equals m times 6.75, I was going to say there, but clearly, I talked about it earlier, but mixing up my x's and y's, so easy to do, And there we have it. So m is equal to 27 over 10, or 2.7 there. Okay, so y equals 2.7x, and that's my equation for L. So it's just something to be careful with here, and I can find n by making this and this equation equal to each other. But I'm actually going to skip past n, as we don't really need it for our regions, and I'm pretty sure you guys can solve that equation quite easily. So let's get on to part C. I'm going to switch back to black for this. So inequalities now. So we want, let's look at it. We want greater than L. So we want y is greater than 2.7x, because it's dashed. We want y is less than x squared minus 5x plus 13, again because that bit here is dashed. Less than this one, but not less than or equal to. Greater than this one, but not greater than or equal to. We need two more coordinates, or inequalities. We want when x is greater than or equal to 0, because clearly we haven't crossed this y-axis. And then we want less than this value of m here, because we need this, don't we? Okay, so this is at 2.5, isn't it? X equals 2.5, so x is less than or equal to 2.5. These final two could be replaced here by just the one inequality between 0 and 2.5. Okay, and that's probably a better way of writing it. So a better way would be these three inequalities. So this one, and this one. And that's it, done. Okay, hopefully, and I'll just get rid of this one just so you can see. Hopefully you've enjoyed this video and you found it useful. If you did, don't forget, like, subscribe, comment, etc. If you find any particularly difficult questions, across anything, feel free to, send me an email with that. You can find the email in the information part, or more specifically the about part. If you click on the about tab on my channel, look to the bottom, you'll be able to get the email address. So if you do find a particularly difficult question, feel free to email me, especially if it's something that you feel that other people might benefit from, and I can make some little additional videos on them. Okay, see you soon. Bye bye.